Okay, so here we are. You've probably just got to the end of the video and you're writing the notes, and we're at this slide here where we've got this light clock. So if you can imagine this light here, this lamp, um, intensity being turned down such that it just releases a photon, and the photon will just make its way to the mirror and then back to the receiver. So we release a photon, there it goes, speed of light to the mirror and back. When the receiver receives it, there's a charge coupled device there, and you hear a click. Okay, so lamp emits a photon or a pulse of light, comes back to the receiver, you hear a click. So what we've got in effect here is a light clock. This is how Einstein went about explaining and deriving the equations for special relativity. So let's have a look now. Let's take this idea a little bit further. I'll walk you through this. So here's our light clock. Okay, and if you can imagine, what I've got here is I've got a clock set up. I've got my light on this side. So sends a pulse, goes to the mirror, comes back, click, click, click. So it travels some length. So because it goes up and back, it'll travel a length of 2L. Okay. So let's now look at our first situation. What happens with our light clock? If we considered a person in a train carriage, okay, in this rest frame, as we'll call it, because this person can't do an experiment to tell if they're moving with some velocity or with zero velocity. So we call this the rest frame, which we've discussed already in class. And what we find is that this person observes this light clock traveling a distance of L plus L, which is 2L. Okay, and we know that the velocity of the light is the speed of light, so we'll call that c. Okay, so let's have a look over here and just apply what we know using this speed equals distance over time equation. So if we have a look, speed the light's traveling is c, the distance the light is traveling is 2L, because it's got to travel from the light to the mirror and back again. And then if we have a look at the time, well, this here is the rest frame. So the notation we use for the rest frame is t0. And the reason why we use that t0 is because we don't know if the object is at rest or moving with a constant velocity. Okay, so because it's a non-accelerated frame or an inertial frame of reference, we use the notation t0 for that. So we can rearrange the equation now, and we have an expression for the time taken for that light to go from the light to the mirror, back to the detector, click, okay, and we have an expression for that, and that's 2L on C, okay?